Alright, welcome in everyone. This is A Programmer Plays Master Keys. We're continuing on with our Nonogram plays, and this video is going to be a little different. In the previous video, I skipped Nonogram 39 because it didn't really make sense with me. I'm going to do it now. I figured out how to do it, and so we're just going to do a little one-off video that covers how to play this particular puzzle, and I don't know, maybe it'll be useful to someone else. We're going to do the same thing that we usually do, where we fill in the stuff that we know is the case. So we know that on this row, there's only one way to fit 3, 1, 3, 1, 3 in a 15 square wide nonogram. We also know that because this column has 3 listed, the 3 couldn't reach any further than here. Same story on this side. We can also look at this and say, all right, we have a vertical 1, 7, so 1 space 1, 2, 3, 4, 5, 6, 7. That has to be filled in. Same for these over here. And similarly, if we aligned it the other way, starting at the bottom, 7, 6, 5, 4, 3, 2, 1, we know that that has to be filled in. That's the lowest arrangement. From here, we kind of get stuck. We can do one more thing, which is say, all right, this middle 1, 1, 3, 1, 1, the middle 3 there, block this off. And then from here, kind of have to start guessing. Now, the thing that we can observe from this is, this is actually symmetric. Vertically, you've got the middle point here, and everything, the columns outside that, one to the left is exactly the same as one to the right. The one beyond that is exactly the same as the one beyond that. We can assume that this is a symmetrical design. It is possible that there's some cleverness there, but it probably isn't. And so let's use that as our baseline and start working from here. So anywhere where we've got a single number or 3 numbers, we know that the middle point is probably filled in. So 1, that probably goes right here. And then the 3 probably goes right here. Then there's another 3 that goes right here. We can go ahead and X these off. Because we've X'd off from this 1, that now gives us a lower bound for our 7 here. We can complete our 7s here. With those in place, we can look at our horizontal 3s and expand out. With this in place, well, okay, we've got some 2s up here. That means that we know that our vertical 2 has to be like that. And then we can similarly look over at this and say, well, this row is nothing but 1s, so we can go ahead and X that out. With that out of the way, we know that the 4 is either part of this, like goes down to here, or starts with this and goes down. So we can go ahead and fill this in. Same story over here. And that also gives us some confidence that this 7 here, it has to be centered. Boom, there's our 7. With that in place, we can look here. Again, this row, or this column is nothing but 2s, so we can go ahead and fill that in. That also gives us our horizontal 5. With that in place, those X's, we can now look at this and say, okay, the only way for this to be a 4 is for this pixel to be filled in. We've got horizontal 1s on either side of this 3, so those have to be X'd out. We can also go a step further down here. We've already got our 4 in place, so those columns can't reach down to here. We're done with these rows, so we can go ahead and X them out. And looking at this column, well, there's only one place for the 2 left to go. Same story over here. And we've only got the 1, 5 here, so that means that we have to fill that in there, and we're done with it. Looking at this row, we've got 3s. Now the 3s could come inwards 1 pixel, and then they would need to have a space here. We can also look at our top up here and say, the 3s don't come inwards because we've got 1s, and we've already got that 1 filled in. In fact, we can go ahead and X all of this out. That means that these 3s have to go outwards. And with that in place, we can now say, okay, that gives us our 1. We need a 2 up here, so that X's that out. Same story over here. Again, this whole thing's symmetric. We've got our horizontal 1s already filled in, so we can X all of this out. Looking down at this row, we can see that we need a pair of horizontal 2s, and we've only got 2 2-pixel spaces left. That then lets us look vertically and say, okay, this one needs a 1, so bam. And we've got to fit a 4 up here, so that's got to fill in those pixels. Same story over here. We then look at this and say, all right, horizontally, we need a 2, and vertically, we need a 2. So this pixel has to be filled in, this pixel, and this pixel has to be not filled in. That also does just complete out this column for us. This needs to be filled in. Now, looking vertically, we say, okay, that's a 3, so that has to be like that. That, and that leaves us with just these 2 pixels here that need to be filled in. And we're done. That gives us this nice little penguin, I think. And that is Nonogram 39. I don't love that you have to guess on this, that you have to look at it and go, this is symmetric, we're gonna have to fill in based on that symmetry. But I couldn't figure out any other way to do it. If y'all know of a way to extrapolate a, this has to be filled in other than it's symmetric, please let me know. I'd be super interested. This one, when I was playing Nonograms 36 through 45, I got stuck. I just couldn't figure out a way to proceed on that short of guessing. So yeah, that's that. Thanks everyone for watching, and I'll see you in the next one. Bye!